We're asked to evaluate this integral of sec x. We all know that differentiation and integration are inverses of each other. That is, if you differentiate a function, the answer, if you integrate it, you now get back the original function. So looking at the trig functions, we know that the derivative of sine is cos, meaning that the integral of cos is now sine. Or maybe the derivative of tan is sec squared, meaning that the integral of sec squared is tan. So but what we have here is sec x. Assuming it were to be sec squared, the answer is tan x. So we're going to use a property. There is one property in integration that integral of f prime x over f of x dx. That's if you integrate a function, a rational function, such that the numerator is the derivative of the denominator, the answer is ln the denominator plus k. So whenever you are to integrate a rational function such that the numerator is the first derivative of the denominator, the answer is ln the denominator plus a. So we're going to use this property to make our solution easy, and also use trig identity, because this thing will have three answers. Integral of sec x will have three different answers. So let's solve. We have integral of sec x dx. Let's do something. Let's, this is over 1. This is over 1. So let's multiply the numerator by sec x plus tan x. So I've multiplied the numerator by that. So we still have to multiply the denominator by sec x plus tan x. So we are still correct. Check. If we cancel, we'll still get back. So let's expand the numerator. So what do you have? We have tan x. I started with this tan x sec x plus sec squared x. We know addition is commutative, so I started with sec x times tan x. I have tan sec. Y sec times x sec squared. I'll repeat this. So what do you notice? If I differentiate the denominator, I will get the numerator. Yes, the derivative of sec is tan x sec x plus the derivative of tan is sec squared s. Therefore, the integral of this, since we have something like this, the derivative of the denominator is the numerator. So the answer is ln sec x plus tan x. So that's our answer. But again, we should know that sec x plus tan x has two other values. So the first one is tan pi over 4 plus x over 2, or is 1 plus tan x over 2 over 1 minus tan half x. That's the same x over 2. So sec x plus tan x is either this or this. So what are we trying to say? I'm trying to say that this has three answers. So it's either this ln sec x plus tan x, or it's ln tan pi over 4 plus x over 2 plus k, or ln 1 plus tan half x over 1 minus tan. Remember, this should be in absolute value, plus k. So these are the three answers for the integral of sec x dx. So to show you that we are correct, I have to prove in another page. I will prove that sec x plus tan s is equal to tan brackets pi over 4 plus x over 2, or is equal to 1 plus tan half x over 1 minus tan. So let's look at this. Tan x plus sec s is equal to tan brackets pi over 4 plus x over 2. Okay. There's one problem students normally make. They always try to prove from left to right, but it's not always true. So you should prove from the side that is easier. So in this case, I will prove from right to left. So once I can prove that right is equal to left, means that left is equal to right. So I will start with, starting from the right, tan pi over 4 plus x over 2. So using our addition formula for tan, this is tan pi over 4 plus tan x over 2 over 1 minus tan pi over 4 tan x over 2. That's, if you could remember, our addition formula for tan, because if you could remember that tan a plus or minus b is equal to tan a plus or minus tan b over 1 minus tan, that's minus plus, it is minus plus. So plus for minus, minus for plus. So if you could remember this formula. So this is this tan 45, that's this. So we have 1 plus tan x over 2 over 1 minus tan x over 2. And we know that tan is sine over cos. So this is sine x over 2 over cos x over 2. 1 minus sine x over 2 cos x over 2. So always know that tan is sine over cos. So let's clear the fraction by multiplying each of them by their LCM, which is cos half x. So cos half x times 1 is cos half x. Cos half x times sine half x over cos half x is sine half x. The same thing, cos half x minus sine half x. So we've cleared the fraction. And again, let's multiply the numerator and denominator by cos half x plus sine half x. So let's multiply this. Let's multiply by cos half x plus sine half x. Cos half x plus sine half x. So we are still correct. So this will give us sine squared half x plus 2 sine half x cos half x plus cos squared half x. So the numerator will we'll expand to that, while the denominator will turn to difference of 2 squared minus sine squared half x. And we know from Pythagorean identity, if you remember, sine squared plus cos squared is 1. So this is 1. While from half angle identity, 2 sine half x cos half x is sine x. That's from our half angle identity, if you could remember. Let me write it here. That's sine x is 2 sine x over 2 cos half x. And again, from our half angles, also from half angles, sorry, we see that cos x is cos squared x over 2 minus sine squared half x. So that this is now cos x. And we can divide both of them by cos x, which is 1 over cos x plus sine x over cos x. And 1 over cos is sec, and sine over cos is tan. So we've proved from right to left. So that's the answer. So we are correct. Thanks.